Hello everyone, I am Dattatreya. Welcome you all on our channel eFunda, new day, new topic. And our today's topic is Introduction to Compressor Engineering. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to the various topics of engineering, fundamental, procurement engineering, project engineering and career, instrumentation and engineering deliverables and many more. And don't forget to subscribe to our channel to get latest notification on upload of our new video on our channel eFunda. So let's begin with our today's topic, that is Introduction to Compressor Engineering. Introduction to Compressor Engineering. Compressors are mechanical devices that compresses gases. It is widely used in industries and has a various application. How compressors are different from the pumps? The major difference is that the compressor handles the gases and pump handles liquid. As gases are compressible, the compressor also reduces the volume of gas. Liquid are relatively incompressible. And now we will see why compressors are needed. Compressors have many everyday uses such as air conditioning, that is car and home and industrial refrigeration, hydraulic compressors for industrial machines, air compressors for industrial manufacturer. Now, so as to understand their various types, one can refer to the image where compressor types are defined, and another figure compressor basic types are shown. Mainly the compressors are divided into the positive displacement and dynamic type. Further, positive displacement is categorized into rotary and reciprocating. Reciprocating is further into the diaphragm and double acting. Similarly, rotary, it will be lobe, screw, liquid ring, scroll, vane type, and one can see their usages and how the typically their construction assemblies are. We will see further more about the compressor and their detail. For better understanding, we will start with the difference between the compressor and the pump. This will help us to understand the working of the compressor and pump. First, the compressor has a compressible working fluid such as an air or gas, whereas the pump has non-compressible working fluids such as a liquid. It increases the potential energy by compressing the working fluid by the compressor. Pump, it increases the kinetic energy of a working fluid, which further raises the pressure energy. In compressor, there is a change in a volume from inlet to outlet, whereas in pumps there is no change of a volume from inlet to outlet. In the compressor, there must be a pressure change during the working operation, whereas the pump, there is a pressure change is not compulsory. Compressor has a storage capability after the compression. Pump doesn't have a storage capacity after pumping. Compressor have a more cost than pumps. Pump has a low cost. Compressor has a high delta P and a low Q factor, that is a flow, whereas the pump has a low delta P and high Q. This is how the compressor and pumps are differentiated for understanding that one is capable for the compressible fluids, another is a non-compressible fluid, and further this difference will help us to understand the compressor and their details. Now moving on to comparison of a compressor types and their applications. Here we will see the main difference between the positive displacement type compressor and dynamic type compressor along with their characteristics, and try to understand the operation and the working and a requirement of the compressor from engineering point of view. First characteristic is the basic operation. Positive displacement, that is a PD compressor, stores a quantity of air or a gas in a compression chamber which compresses it, thus reduces its volume and it leads to the increase of its pressure. Similarly, in the dynamic compressor uses impellers that change the velocity of air into the pressure with the help of volute or the diffusers. Selection characteristics: positive displacement types works are selected based on the characteristics of a constant flow, B low or a moderate flow or a high head, C flexibility in capacity and a pressure range, D higher efficiency and a lower power cost, E less sensitive to changes in gas composition and density. Whereas in the dynamic air compressor include centrifugal and axial machines types: A constant head, high flow, low heads, B flow reduces with a higher back pressure, C multi-stage for high discharge pressure, and are used in very large manufacturing facilities. Working principles: in positive displacement compressors, the air taken into the compressor is held within the compression chamber. In dynamic compressor, the air is constantly rotated with the impeller to increase its kinetic energy capacity to handle. The positive displacement compressor handles small volume of air, while the dynamic compressor handles a large volume of air. Pressure ratio: PD compressor offers a high pressure ratio since they handle small volume of air, while dynamic compressor provides a lower pressure ratio since they continuously handle air in large volumes. Further classification: positive displacement type compressor are further classified into A reciprocating compressor, contains an assembly of a piston and a crankshaft, as this assembly helps when the gas is sucked inside the compressor, and a crankshaft mechanism will produce a reciprocating motion and will move the piston in order to compress the gas. One can see the picture below where the piston and a crankshaft arrangement shown. Similarly, the other type is a rotary compressor. Rotary types of a positive displacement compressors one can see in a picture, containing some rotating mechanism which helps to draw in the gas and discharge it to the requirement. This is how the classification is done in a positive displacement type. Similarly, in the dynamic compressor type, A centrifugal compressor, the impeller rotating at a very high speed sucks in gas and accelerates it to such a high velocities that in some cases the velocity of the moving gas reaches to speed of the sound. One can refer to the picture below where one can see the impeller assembly. Before such a high velocity gas is discharged, it is passed through a section of a increased area. This causes the kinetic energy of the moving gas to get converted into the static energy. Similarly, the other type is the axial compressor. This contains a set of airfoils. One can see in a picture below are stacked in a row. The rotating movement of the airfoil progressively compares the gas. They can achieve high flow rates in a compact design due to this feature that they turn out to be quite expensive. Now we will see the operating speed. PD type compressor operates at the lower speed, whereas the dynamic type operates at the super fast speed. Duty operation: PD type compressor are intermittent when it comes to the air supply, while the dynamic compressors are continuous duty compressors. Operating area of operation: in PD compressor, the pressure discharge of the air doesn't depend on the shape of the plunger as long as the plunger does its work correctly, while in the dynamic compression, the pressure head of the discharger depends on the shape of the impeller blade. This is how we have tried to cover the comparison of a compressor type, their application, and we have tried to cover the basic introduction of the compressor where it requires from the engineering point of view. For more detail, one can refer to the project specification, compressor data sheets, and the specifications from the kind for the better understanding of the subject. Similarly, one can refer to the international codes and standard related to the compressor and their application study. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.